Welcome back to the reporting session. So in this session, we are going to report our findings from the previous videos. So in this session, we consider our KMO, and then we have our communality table, we have our total variance, we have our rotated matrix, component matrix, and then we also have our script plots. So now when we come to the KMO, we talk about the adequacy of the data, and then the Bartlett test is also talking about the relationship, whether there exists a strong relationship among the data. And then we focus on, with the KMO, we focus on this, and then the Bartlett test, we focus on that. This can also be used for decision making in the chi-square value. So let's see how we present it. Table 1 present the results of Kesa-Mayo, just in short, KMO measure and Bartlett test of sphericity. The KMO value of 0.841 indicates good sampling adequacy for factor analysis. The Bartlett test of sphericity was statistically significant. At p-value, we have the chi-square, but the p-value is where more of our attention is, because it's easy to interpret that one. This one, you have to go and get the table and compare. So this one, you just compare it to the 0.05. So suggesting that the correlation matrix is not just an identity matrix. So the correlation matrix is not just an identity matrix. What does identity matrix mean? Identity matrix, it means that there is no relationship within the variables. So when we have the matrix, there is no relationship among them. So let me show something here. The results, maybe you can understand something I'm trying to say. So this is a matrix. So aside the leading diagonal, the rest here are just 0, 0. So that is what we call the identity matrix. And then we come to the communalities. So how do we present the communalities? Table 2 present the communalities of the variables after extraction. The results indicate that all items have high communalities ranging from 0.806 to 0.865, suggesting that a substantial proportion of each variable's variance is explained by the extracted component. This confirms that all items are represented in the factor solution and are suitable for inclusion in the model. So that means that each and every one of these one fits into the group well, because I already explained values you have to consider. That is 0.5 and above, and all of this one are far more than 0.5. And then we come to total variance explained. So we have our component, our agent values. We have variance for each and every one of these components, and then the cumulative, that's in all. So table 3 shows the total variance explained by the extracted components. 3 components with agent values greater than 1 were retained. So these are the 3 components. And then explaining 37.48 by component 1, this one 25 by component 2, and then component 3 respectively. So explaining 37.487%, 25.094, and then 20.838 of the total variance respectively. That means component 1, component 2, component 3. Together, this component account for a cumulative variance of 83.419%, indicating that factor model explains substantial proportion of the variability in the data. So 83 point something is enough to represent the entire group. And then the rotated components. So now these particular components, B1, B2, so when you come here, you could see that B1 So B9, B10, B11, B12. So B9, the university monitors energy use and environmental impact. So we have monitor here, and then environmental policy guide. Guide is also just about monitoring, and then staff are aware of substantial policy related to facility management. So awareness is just trying to monitor. They are also, so facility management reports. So now they get aware, they monitor and then they support. So we place these ones under monitoring and support. Instead of now going by each and every one of these, we just use monitoring and support. And then this one, waste management are implemented effectively in campus. So energy resource management, and then energy, and then we also have management here. The university actively manages electricity. So all these ones also fall under energy and resource management. And we also have, so you can pause and then just check these ones. So that is what we have just done, indicated here. So that is the concept of the component matrix. So table 4 represents the rotated component matrix obtained using Varimax rotation. The results reveal a clear three-factor structure. The first component comprises variables B9, B10, B11, and then B12, which are related to monitoring and policy-related practices. The second component indicates, include variables B5, B6, B7, and B8, representing sustainable operational practices. The third component, B1, B2, B3, B4, which captures energy and resource component. So all variables loaded strongly on their respective component, with factor loadings exceeding 0.88, indicating a well-defined and reliable factor structure. And then the script plot here is just confirming. So figure 1 presents the script plot of eigenvalues. The plot shows a clear point of inflection after the third component, supporting the retention of three components. This confirms the results obtained from the eigenvalue criteria. So that is how we go by reporting our findings for factor analysis. So if you are able to put these ones, they are enough for your factor analysis. You don't need much. So you stay tuned. We'll continue for our next video, hopefully next 2 weeks. Have a great time.